Welcome back, Math 8. Today we are continuing our linear relations and equations unit. To be fair, linear relation part, we're going to put a little pause button. We're going to go back to a little bit of equation. To be fair, this first lesson will be quite a lot of review from, it has been a while, but there was a time we did grade 7 equation review, so it's going to be quite similar. The only difference is we're going to go through two different methods. One they use mental math, which is opposite operation, and another part they use modeling, which is kind of like a scale model. And we're going to go through obviously one step equation today. Oh my. There you go. There you go. That's more like it. This is available on page 23, by the way, of your lesson booklet. From grade 7, we know that when we solve an equation using algebra, we must preserve the equality. So what I mean by this equality, that means you need to understand that equation have an equal sign. So if I talk about that as a quick example, you always have left side, and generally left side people try to put x, y, z, those kind of unknown variable, and on the right side you generally have some kind of constant. But long story short, you have to put left side and right side, and those are equal together, just for the heads up. This is one thing that you need to understand. Whatever we do on one side equation, we must do the same to the other side. This is another emphasis that I have been made, and this is generally known as opposite operation. If I add something on the left side, I have to add the same thing to the right side. If I multiply something on the left side, then I should do the same thing on the right side, something like that. Having an equal sign means, ladies and gentlemen, that means whatever that I'm applying for left and right side has to be fair. That's what I want to point that out to you. Oops, what I wrote disappeared. There you go. You have to be quite fair. Oh my writing is horrible using this screen, so I'm gonna try to type more. So, like I mentioned, if I add something, then I should do the both sides, subtract, multiply, division. Any of these guys, you need to do same for each of the side. I should have highlighted. We are going to kind of skip this online activity. Feel free to go there because you can actually use the algebra balance scale. This is actually the first method that we're going to go through, algebra balance scale. And we're going to use several examples using those algebra balance scale. So I have that in your mind. And we are going to create some of the example on the page right next to the lesson page that we were in, which is equation 1. We're going to go through visual representation and symbolic solution. So when it comes to visual representation, you can consider that this is algebra balance model method. You can think it in that way. Symbolic solution, we're going to use mental math skill, which is opposite operation skill. When we try to double check whether we're on the right track or not, whenever we solve the question, that part comes in for the last step, which is verification step. So I'm going to highlight this one. Verification means, ladies and gentlemen, it's a fancy way of saying substitute and double check. All right, let's do a first example. And I'm going to choose something that is more appropriate or a little bit challenging compared to what you guys did in grade 7. So it will have quite a lot of negative numbers in it. Um, so let's say we have an equation x minus 2 that is equal to negative 5. Now, if we use algebra balance model, here are several things that you need to understand. And this will change all the time. It's not something that is carved on stone. So please have that in your mind. Um, let's see. We are using some tile, but except these tiles, ladies and gentlemen, can be. Oh, can I not? Okay, why not? There you go. I try my best. If you have a small square that is colored, you can think that this is positive 1. If you have an empty one, you can consider that as negative 1. To be fair, ladies and gentlemen, this rule is just one of the way of showing the algebra tile model. It may not be 100% colored one is always positive, empty one is always negative. There's no things like that, just for the heads up. It really depends on situation. um, Other thing that I'm gonna put, unfortunately it's not here, so I'm just gonna draw. If you have long ish, if you have longer strip, but if you have anything that is colored inside, then we're gonna call that as positive whatever the variable, like positive x. If you have empty one, then you probably guessed it, negative x. So the way that you use your algebra balance model is we are going to build some kind of seesaw, like wooden plank, have a little bit of a center of the seesaw, which represent equal sign. And on the left, we're going to put what we see on the left side, x minus 2.
It's another Flashlight Friday here at HFCS. Lights are going off.
Oh boy, I hope our class doesn't have that. X minus 2. First of all, x is positive, so that means I have to have x strip with colors. On the other hand, there you go. On the other hand, when it comes to negative 2, that means I have to have 2 of a square that is empty. So something like that. So I have one positive x, negative 1, negative 1. On the other hand, on my right side, I have negative 5, so I should have 1, 2, 3, 4, 5 integer tile that is negative. This is what happened. However, the main goal of solving an equation, ladies and gentlemen, is basically isolating. We want to have just that color strip on one side. So how can we make that happen? Well, it is simple. Like I mentioned, start with the seesaw. And here's what I do. We have one strip on the left side. Then what should I do? I have to move these guys to the other side. We call it operation, if you will, when it comes to mental math. But long story short, we are just trying to move one to the other side. Transfer is what I like to call. The way that you move this is making entire thing as zero pair. Zero pair means, ladies and gentlemen, you are mixing color tile and non-color tile on purpose. So what I mean by that is I have two empty tile over here. So if I introduce color tile on left side, you will notice that my negative and positive will be cancel each other. White doesn't show as a pink. There you go. This is what we call zero pair. The color tile and non-color tile cancel each other. And you guys learn about that in science, in math 7 too. The one thing that you need to understand, however, if I add these two tiles to make a zero pair, I have to do the same thing. That is what I mean by that at the very beginning. But once that part is done, the next part is simple. I'm gonna cross this pair out, and I'm gonna cross that pair out. So long story short, I only have 1, 2, 3 integer tile left. And you guys remember that the first one, the one that you see on the left side, color strip, that's positive x, that is equal to 3 empty 1, negative 3. This is how you do. Now, verification. How can I verify if I'm on the right track or not using this setup? Well, sorry, I keep going up and down like crazy. This thing is very sensitive. Can you see that there is an x minus 2 that is equal to negative 4? You are substituting your answer into that spot over here. So instead of x, you're putting negative 3. And then you're going to check whether that solution comes out to be negative 5. So x negative 2 was negative 5. If I substitute x as negative 3 in there, then you will write down that negative 3 minus 2 is what you have. And as you may notice, if you think about this as a number line, you're going 3 to the left and 2 to the left. So as total, I have negative 5. And as you may notice at this point, you can literally see that my right side answer and left side answer are agreeing each other. So you can conclude that these guys are the proof that my work is on the right track. If I use mental math method, ladies and gentlemen, then I'm going to put that over here. I want you to start with the number that you have, x minus 2 that is equal to minus 5. One thing that I'm going to focus if you're doing mental math is this portion minus 2, because I am going to use opposite operation. Opposite of negative 2 means positive 2. So x minus 2, positive 2. But I need to do the same thing to the other side. If you do this, minus 2 and positive 2, these guys cancel each other, because that make zero pair. So x is equal to negative 5 plus 2, which is minus 3. That's how you solve one-step equation. To be fair, we already learned about this a little bit. The only complication is negative and positive. You need to understand the differences, how they are applied. We're going to go through more of that balanced example using the model. The next example, I'm going to go through slightly different type. 4c is equal to 12. So right now, one thing that you need to understand that this is multiplication going on, because 4 and c, you don't see any addition or subtraction going on. If it was division, you will see 4 over c or c over 4, right? Depends on that situation. Now, without further ado, let's go with our algebra method. So here's the thing. 4c, that's a fancy way of saying I have to draw 4 strip. Any variable is a strip, ladies and gentlemen. 2, 3, 4. I'm going to use the same rule that I use. I believe I mentioned colored is basically positive. Actually, let's make it a little bit more tricky. Can you guys put -12? There you go. Which is not as different, but it's just a good idea to represent. Got a little lazy, so I'm gonna just use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, why not? Imagine it's all going around. But as long as you see that there's about 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, those are the good setup. You need to understand that according to our model, these guys should be equal together. What's on the left side, what's on the right side should be equal. However, as you may notice, the big goal that you need to have it in your mind whenever we are solving any type of equation is we need to isolate how can we make c is equal to something in this situation, or x or y, depends on whatever the question that you have. We gotta make it how one x strip, or c in this case, is equal to. It seems like it's taking a long time, so there you go. There's a strip equal to question mark. Oh gosh, this is actually giving me such a hard time. There you go. But here's the thing. Should I add zero pair on left side and right side using the strip? The thing is you cannot, because you already know that adding and subtracting and making a zero, you can only do for integer tile like what you see, the square little one, adding or subtracting. If you have more than one of the strip that is given, here's what I recommend you to do. You need to distribute other side evenly for each of them. What I mean by that is there any way this unorganized 12 tile can be belong to each of this strip? So what I mean by that is this one strip can have one empty, second empty one. Oh, hurry up. Third. When it comes to second strip, I can make it belong 1, 2, 3. Sorry guys, I think the internet connection in the school is not the best today. Same thing happened for the others. So once you evenly distribute these pair, you will notice that 1x can have 3 empty tile. If I look at the other one, same amount. Third one, same amount. Fourth one, same amount. So long story short, I can have 3 empty tile that belong to each of an x. So you can conclude that each x, so in this case color strip, can have -3. So 3 of an empty tile. That's how you can do. And you can double check. We said 4c is equal to -12. And if c is equal to -3, that means 4c, which is fancy way of saying 4 times -3, should give you the same number that you see on the right side, which is 4 times 2. 4 times 3 is 12. Positive and negative give you negative. So as you can see over here, my right side value and my left side value, they all agree to each other. Equal together. If you're using opposite operation, which I'm gonna go up a little bit, then you gotta use opposite operation of mental math. 4c is equal to -12. As you may notice, if I expand, 4 times c is equal to -12. That is equivalent as c times 4 is equal to -12. Order really doesn't matter. And your job is basically figuring out what's the opposite of this expression over here. Which is multiply by 4. Opposite of multiplication, multiply by 4, it's a fancy way of saying you are divided by 4. Or -12 divided by 4. Then you will notice that multiply by something and divided by something, these guys cancel out. And only thing that is left over on the left side is just c. So I can say c is equal to -12 over 4, which is -3. That is today's lesson. Some of them will be a little review from the previous math course, but some of them may be relatively new, especially the tile method over here. Sorry about the glitches and delay in time a little bit. And your homework will be solving every question on this page 26. That is today's assignment.